Hello everyone and welcome back to another video. In this one we are going to discuss about MCQs on discrete probability distributions. So this is going to be a miscellaneous MCQ topic that we are going to cover specifically for discrete probability distributions. So the first question says, which of the following is a required condition for a discrete probability distribution? So let's not look at the options. Let us just focus on what we know, right? So we definitely know that summation of fx is equal to 1. F of x will always be greater than equal to 0, okay? And f of x will always be less than equal to 1, okay? So this is all we know, and let's see what all matches. So of course f of x cannot be equal, summation of f of x cannot be equal to 0. This is wrong. F of x is always greater than equal to 1. This is wrong. It is always greater than equal to 0. F of x is less than 0. This is absolutely wrong. F of x or probability, it can never be negative. So it can never be less than 0. The D option is correct, that summation of f of x is equal to 1. So our option is D. Next up, a measure of average value of a random variable is known as expected value. This is something that we have covered before. Okay. Next up, which of the following is not required condition? Okay. So the first one is true as discussed before. If we go and look back here, f of x is greater than equal to 0. This is right. This is the right. Summation of f of x is equal to 1. This is also correct. Summation of f of x is equal to 0. This is wrong. Okay. Alright. Moving forward. The standard deviation is so we know that standard deviation is nothing but under root of summation of xi minus x bar whole square by n. Okay, this is your standard deviation. So it is definitely not variance squared. In fact, variance is nothing but square of standard deviation. Okay, so the first option is wrong. Square root of sum of deviations from mean. This is also wrong. It is not just square root. It is square root of square of deviation. Square of deviation from mean. So this is also wrong. It is same as expected value. Absolutely wrong. It is a positive square root of variance. That is correct. So if we go look at this, vice versa, it is nothing but under root of variance, and it is obviously positive since it is a square. So the correct answer is option D. Next up, in an experiment consisting of 80 phone calls in order to sell a particular insurance policy, the random variable in this experiment is, so since it is countable and there is no continuous matter going on, we can never have decimal values when it comes to number of phone calls, right? So it is a discrete random variable. Next is, an experiment consists of determining the speed of automobiles. So when it comes to speed, we know that it can be plotted on a continuous scale. It can have decimal values like 55.5 kilometer per hour or anything, right? So this is a continuous random variable. Okay. Next is, the number of electrical outages in city varies from day to day. Assume that the number of electrical outages X in the city has the following probability distribution. So we need to find the mean and the standard deviation. So we know that mean is summation of x f of x. So if we expand this, we get 0 into 0.8 plus 1 into 0.15 plus 2 into 0.04 plus 3 into 0.01. So if we go ahead and solve this, we will get the value as 0.26. Okay. So this is your mean. Okay. Now, if we have to also discuss about the variance. So variance will be calculated as expectation of x square minus expectation of x whole square. Now if we try to find expectation of x square, if you remember, it will be nothing but summation of x square f of x. If I open this up, we will have 0 square into 0.8 plus 1 square into 0.15 plus 2 square into 0.04 plus 3 square into 0.01. So this is how we will get expectation of x square. We will subtract this value from expectation of x whole square, which we already calculated as mean, which was 0.26, right? So using this, when we solve this thing, we will get the answer as 0.3329. So this is nothing, this is the variance, okay? When we underroot this value, we get 0.577, which is the standard deviation.